In junior high school mathematics, you will encounter solving linear inequalities for grade 7, solving quadratic inequalities for grade 8 and for grade 9. This time, let us familiarize the different inequality symbols. First, we have the greater than, the less than symbol, greater than or equal to, and less than or equal to symbol. Aside from grades 8, 7, 8, 9, for grade 11, you also have the rational inequalities. So you better watch this video and understand different signs in our inequalities. To write our final answer, we have the interval notation. Okay. This is very important. You're going to write your final answer in interval form or interval notation. So how to do the interval notation? Let's say we're going to check or to test our final answer. So we're going to use the number 9 to test our final answer. Let's say in our final answer, we have this output. Okay. So -1, we have a hollow or a circle here, then going to positive infinity. So before we write that in interval form, let us first familiarize the different symbols that we're going to use. Okay. If you will encounter the symbol, this is what we call the open. And the shaded part is what we call the close. If we encounter the open symbol, we will use the open parentheses or the closed parentheses. And if our symbol is closed or the shaded one, we're going to use the bracket sign. Now, let us write this in interval notation. So, open to -1. So, open and write the number -1, comma. Then we're going to positive infinity. So, positive infinity. Now, what are we going to use? The open or close? Since we don't know, or we do not know where it ends, because this is infinity, we're going to use the open symbol. So, open to -1, that means -1 is not included. Then going to positive infinity. Another example. Let's say this is our number line. Then this will be our inequality. This one. So we have in -1 and in +2. So let's start on the left side of our number 9. This is going to negative infinity. So since we do not know where it ends, so this will become open to negative infinity. Okay. Then -1, it is shaded. So that means -1 is included. So negative 1. Since this is closed, we're going to close bracket. Now we have another answer on the positive side. So we're going to use union. This is a grade 7 lesson, union. That means it is included. Open to positive 2. Open to positive 2. Then we're going to positive infinity. So this is also open. Did you get it? Now, another example. What if we have 0, 1, 2, negative 1, negative 2. What if your inequality is close to negative 2, going to close to positive 2? So since you are close to negative 2, close to negative 2, then also close to positive 2. Positive 2 and close. Okay. Now, I want you to try the following example. Try to write the following into interval notation. What if you have, for number 1, so this is 0, 1, 2, 3. Negative 1, negative 2. Open to negative 2, then open to negative 3. You can pause the video if you want to try this one. And after answering, you can resume watching the video. Now let us try. Open to negative 2. Open to negative 2 and open to negative 3. Open to positive 3. Positive 3, that is open. That means negative 2 is not included and 3 is not included. But 1.99, 1.98, negative 1.97, negative 1.99 is included. Positive 2.99 is included, but not positive 3. How about this one? 0, 1, 2, 3, 4. Negative 1, negative 2, negative 3. Okay. I want you to solve number 2. Get your notebook, then try answering. You can also pause the video. If you are done, resume playing, then let us check your work. So we are going to negative infinity. So open to negative infinity and negative 1. Close or open? So shaded, that means we're going to close to negative 1. Union, close to positive 3. Close to positive 3. Then we're going to positive infinity. This is positive infinity. We're going to use the close parenthesis. Okay, that is the inequality and the interval notation. Again, this is very important. Our topic is solving linear inequalities. Let's try to solve number 1. 5x plus 1 is less than 11. Again, let us repeat the given. 5x plus 1 is less than 11. So we're going to solve for x. To solve x, let us use the addition property of inequality. Let us subtract 1. So 5x is less than 11. So our easiest way is to transpose positive 1. That is negative 1. 5x is less than 11 minus 1. That is 10. Now, divide by 5. So x now is less than 10 divided by 5. That is 2. Okay. X is less than 2. Let us try to write this in our number line. Let us graph in our number line to find our interval notation. So this is 0, positive 1, positive 2, positive 3, negative 1, negative 2, and so on. Less than 2. So that means 2 is not included. So we're going to leave it open. Open to negative 2, less than, going to negative infinity. Okay. So our interval notation for our final answer, that is equal to open to negative infinity, then open to positive 2. This is now our final answer. Now let us try number 2. 3x plus 9 is less than or equal to 0. Again, let us find the inequality. First, transpose positive 9. So this will become 3x is less than or equal to negative 9. Next, divide negative 3 to both sides of the equation. So x is less than or equal to negative 3. Let us plot in our number line. So 0, negative 1, negative 2, negative 3, negative 4, negative 5. Positive 1, positive 2, positive 3, positive 4, and so on. X is less than or equal to negative 3. We have equal to negative 3. So that means negative 3 is included. So negative 3 included, so we're going to shade negative 3. Less than negative 3 is on the left side. So we're going to negative infinity. Use the arrow sign. So for our final answer, negative 3 to negative infinity to negative 3, but negative 3 is included, so we use the bracket to close our final answer. Negative infinity to negative 3. Third example. Negative 3x plus 5 is less than or equal to negative 22. Okay. Negative 3x plus 5 is less than or equal to negative 22. First step, isolate our variable. So, negative 3x is less than or equal to negative 22 transpose minus 5. And next, negative 3x is less than or equal to negative 27. To find x, divide both sides of the equation by negative 3. So x is now negative 27 divided by negative 3. This is positive 9. Our rule in this inequality is, if we're going to divide negative or multiply negative, we need to change our inequality sign. So that will become greater than or equal to positive 9. Again, if you're going to multiply by negative or divide by negative, you need to change our inequality sign for greater than or equal. Greater than or less than. Change the inequality sign. Now, let us plot in our number line. Where is 9? So, if this is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, then the negative numbers, negative 1, negative 2. X is greater than or equal to 9. So 9 is included. Greater than. So on the right side of 9. So for our interval notation, we're going to close to positive 9, then going to positive infinity. Now, our parenthesis sign. That is on how to solve linear inequalities. Again, our rule is, if you're going to divide by 9 or by negative or multiply by negative, you need to change the inequality sign. Our topic is solving quadratic inequalities. For grade 9, you have your quadratic equation. But what if we have these quadratic inequalities? Let's say we have problem number 1, x squared plus 7x plus 10 is less than or equal to 0. Okay. So if it is equal to 0, that is easy because we already discussed that in our equation, quadratic equation. But if we have less than or equal to 0, so just like solving quadratic equation, we're going to factor our trinomial. To factor this, our shortcut is the product of factors of 10, which is, if you're going to get the sum, that must be equal to 7. Obviously, that is 5 times 2. So x, positive 5, positive 2. 5 times 2 is 10. 5 plus 2 is 7. Now, after getting the factors, find the zeros of our quadratic inequality. So our zeros just equate to 0. So x plus 5 is equal to 0. then x plus 2 is equal to 0. So x is equal to negative 5 and x is equal to negative 2. This will be our zeros. Now, next step, you need to plot in our number line. Okay. Let's say this is our number line. We have 0, positive 1, positive 2, positive 3, positive 4, and we have the negative numbers, negative 1, negative 2, negative 3, negative 4, negative 5. Let us extend negative 6. Okay. After getting our number line, locate negative 5. Where is negative 5? Negative 5 is here. And negative 2. Negative 2 is here. Now let us test our inequality. Less than or equal to 0. So let us check the numbers on the left side of our negative 5 first. Of course, on the left side of the negative 5, we have negative 6, negative 7, negative 8. So let us check one number on the left side. Let us check negative 6, or if you want negative 7, that's okay. So copy the factor. So that is x plus 5 times x plus 2 less than or equal to 0. So I will use negative 6 to test, or to check. So negative 6 plus 5, and just substitute the value for x, negative 6 plus 2. It's less than or equal to 0. So negative 6, I just substitute to x. Okay, then simplify. Negative 6 plus 5, that is negative 1. Negative 6 plus 2, that is negative 4. Less than or equal to 0. Negative 1 times negative 4, that is positive 4. Less than or equal to 0. Is 4 less than 0? No. So that means this is false, because 4 is greater than 0. So that means all the numbers on the left side of negative 5 is not included, because we have the answer of it doesn't match. So this is false. How about in between negative 5 and negative 2? Let us choose negative 4 or negative 3. If you want negative 4 or negative 3, that's okay. Just pick one number. Okay, I will choose negative 4. It's up to you. If you're going to choose negative 3, it's okay. So I will choose negative 4. So I need to substitute as our x. So negative 4 plus 5 and negative 4 plus 2 less than or equal to 0. So negative 4 plus 5, that is positive 1 times negative 4 plus 2, negative 2, less than or equal to 0. Now we have 1 times negative 2, negative 2 less than or equal to 0. Is negative 2 less than 0? Yes. So that means this is true. True. And last one. Let us check the numbers on the right side of negative 2. You can choose between negative 1, 0, 1, 2, 3. It's up to you. But I'm going to choose 0 because this is the easiest one. So I will substitute 0 to our x. 0 plus 5. 0 plus 2 less than or equal to 0. 0 plus 5, that is 5. 0 plus 2, that is 2. Less than or equal to 0. 10 less than or equal to 0. Is it true or false? This is false because 10 is greater than 0. Take a look at our answers. False, true, and false. That means in our inequality, these numbers satisfies our inequalities. So, as our final answer, using interval notation, so we're going to close. Why close? Because that is equal to -5. And we're going to close to -2 as our final answer. Why close? Because -5 and -2 are included. So our numbers are just the following: -5, -4, -3, -2. Those are the numbers that will make our inequality true or correct. Now, I want you to answer this problem. Our problem number 2 is x squared minus 2x minus 15 is greater than or equal to 0. Again, x squared minus 2x minus 15 is greater than or equal to 0. Please try to answer that given, and if you are done answering, please proceed in our next video to check your work. I will put the link in the answer key of our given problem at the end of that video. Our problem is x squared minus 2x minus 15 is greater than or equal to 0. Our first step, we need to factor our trinomial. So our factors are factors of -15, wherein the sum is -2. So that is -5 and +3. -5 times +3, that is -15. -5 plus +3, that is -2. Second step, find the zeros of the quadratic inequality. So our zeros are, just equate to 0. X plus 3 is equal to 0. So x is equal to +5 and x is equal to -3. So this will be our zeros. Take note, that is not yet our final answer. Now, using our number line, locate +5 and -3. This is our number line. 0, 1, 2, 3, 4, 5, 6, so on. So +5 and -3. -1, -2, -3. Okay. Then -4, -5, and so on. And let us check whether the left side of -3 satisfies our inequality or not. So pick a number on the left side of -3. -4, -5, -6, -7, it's up to you. Let us choose negative 5. Copy the factors. X minus 5. So my x is negative 5 minus 5 times x is negative 5 plus 3. Greater than or equal to 0. Let us check if this negative 5 satisfies our inequality. Negative 5 minus 5, this is negative 10. Negative 5 plus 3, that is negative 2. Greater than or equal to 0. Negative 10 times negative 2, this is 20, positive 20. Greater than or equal to 0. Is 20 greater than 0? Yes. That means this is true. Okay. Next. Now, let us choose between the following numbers, negative 2, negative 1, 0, 1, 2, 3, or 4, to check whether it satisfies our inequality. Let us pick the easiest one, 0. So, change x to 0. 0 minus 5. 0 plus 3, greater than or equal to 0. 0 minus 5, this is negative 5. 0 plus 3, positive 3. Greater than or equal to 0. Negative 5 times positive 3, negative 15, greater than or equal to 0. True or false? Negative 15 is less than 0. So this is false. That means the following numbers does not satisfy our inequality. Okay, let us neglect those numbers. Now, let us try the numbers on the right side of positive 5. Okay, choose 6, positive 6, positive 7, positive 8, positive 9, positive 10. It's up to you. But I will pick the smallest one, the 6. So x will be 6. So 6 minus 5, 6 plus 3, greater than or equal to 0. 6 minus 5, that is 1. 6 plus 3, that is 9. Greater than or equal to 0. 1 times 9, that is positive 9. Greater than or equal to 0. True or false? This is true. So that means our interval notation, our final answer is, this is true. We're going to negative infinity. So open to negative infinity. Then negative 3. That means we have equal to negative 3. Open or close? So negative 3 is included because we have the equal sign. So we're going to close. Union 5. 5 is also included. 5 to positive infinity. This is now our final answer in our quadratic inequality. Again, please make sure that you watch our tutorial videos in inequalities and interval notation. And of course, our problem number 1 in solving quadratic inequalities to better understand this problem. Our topic is solving rational inequalities. Our root word is ratio. So we are dealing with our rational expression, rational inequalities. Let's try number 1. 2x plus 10 over x plus 3 is greater than or equal to 1. Again, 2x plus 10 over x plus 3 is greater than or equal to 1. So our first step is our inequality must be equal to 0. So we need to transpose positive 1. So 2x plus 10 over x plus 3 minus 1 is greater than or equal to 0. Okay? That is our first step. The inequality must be equal to 0. Now, simplify the left side of our inequality. So we need to find the LCD. Our LCD is x plus 3. So just copy x plus 3. X plus 3 divided by x plus 3, that is 1. So 1 times 2x plus 10, so 2x plus 10. Next, we know that the denominator of 1 is 1. So x plus 3 divided by 1, that is x plus 3, times negative 1. So that is negative 1 times x plus 3. It's greater than or equal to 0. Okay. In this case, we need to simplify our numerator. So copy 2x plus 10, negative 1 times x, this is negative x, negative 1 times positive 3, negative 3, over x plus 3. It's greater than or equal to 0. Simplify our numerator. This will become 2x, 10 minus 3, plus, okay, we need to combine 2x minus x, that will become x. 2x minus x is x. Next, 10 minus 3, that is positive 7, over x plus 3. It's greater than or equal to 0. Okay. That is now our simplest form. Second step, find the zeros of our rational inequalities. So find the zeros. Zeros. So our zeros are x plus 7 just equate to 0. So x is equal to negative 7. Then x plus 3 is equal to 0. X is equal to negative 3. This is now our zeros. Negative 7 and negative 3. Now, we need to locate in our number line. Plot in our number line. So let's say this is our 0, positive 1, positive 2, positive 3. Negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, negative 7, negative 8, negative 9. Locate negative 7. Negative 7 is here. Okay. And negative 3. Negative 3 is here. Now let us check which of the following satisfies our rational inequality. So let us test the leftmost part of our number line. So you need to choose negative 8, negative 9, negative 10, negative 11. It's up to you. In this case, let us try negative 10. Like negative 10 or negative 9. Okay. Let us use negative 10. So, substitute our value of x to negative 10. If x is equal to negative 10. So, negative 10, just change to negative 10 or substitute, plus 7 over x is negative 10 plus 3 greater than or equal to 0. Negative 10 plus 7, that is negative 3 over negative 10 plus 3, negative 7, greater than or equal to 0. Okay? Negative divided by negative, that will give us positive 3 over 7. It's greater than or equal to 0. 3 over 7. Is it greater than 0? Yes, it is. So, if x is negative 10, this is true. Okay. Of course, if x is negative 9, that is also true. And if x is negative 8, that is also true. All the numbers on the left side of negative 7. Now, let us test the numbers between negative 7 and negative 3. So, pick one number, either negative 6, negative 5, or negative 4. Let us choose negative 4. If x is equal to negative 4, then substitute negative 4 plus 7 over negative 4 plus 3. Is it greater than or equal to 0? Now let us check. Negative 4 plus 3, that is positive 3 over negative 4 plus 3, negative 1. Greater than or equal to 0. 3 divided by negative 1, that is negative 3. Greater than or equal to 0. Is negative 3 greater than 0? No. So this is false. Okay. So the following numbers are not included, negative 6, negative 5, and negative 4. How about the numbers on the right side of negative 3? So let us check 0, because 0 is the easiest one. So if x is equal to 0, so 0 plus 7 over 0 plus 3 greater than or equal to 0. 0 plus 7, 7 over 0 plus 3, 3 greater than or equal to 0. 7 over 3 is greater than 0? Yes. So this is true. So we're going to get the left side of negative 7, because that will make our inequality correct, and the right side of negative 3. So to write our final answer, open to negative infinity and 7, that is close. Why close? Because that is equal to, greater than or equal to. Union, close to negative 3, going to positive infinity. This is now our final answer. Negative infinity to negative 7, close. Union, close to negative 3 to positive infinity. So that is on how to solve rational inequalities. Now, I want you to solve this problem. Three x minus 15 over x less than or equal to 5 minus x. Okay. Try to solve this. 3x minus 15 over x is less than or equal to 5 minus x. To check your work, the checking of the problem 3x minus 15 over x less than or equal to 5 minus x. That is your assignment in our tutorial video last time in problem number 1. Now let us check your work. Our first step, the inequality must be equal to 0. So let us move 5 minus x on the left side. So use the addition property of equality. 3x minus 15 over x minus 5 plus x is less than or equal to 0. Okay. This is now equated to 0. Now, find the LCD. Our LCD is x, our denominator. So x divided by x, that is 1, times 3x minus 15. So that will give us 3x minus 15. Or just copy because this is already equal to x. Now, x divided by 1, we have a denominator of 1 here, times negative 5, negative 5x. And x divided by 1 times x, positive x squared. It's less than or equal to 0. Now, simplify our numerator. Then arrange from descending order. So, x squared, 3x minus 2 minus 5x, negative 2x, minus 15 all over x is less than or equal to 0. Okay. Now, since this is quadratic, find the factors. So factors are factors of negative 15. The sum must be negative 2x. So that is x minus 5 and x plus 3. Let us check. Negative 5 times positive 3, negative 15. Negative 15 times 3, negative 2. Okay. For our next step, find the zeros of our inequality. So just equate to 0. X minus 5 is equal to 0. That will become x is equal to 5. So the zeros are 5. The other one, x plus 3 is equal to 0. So x is negative 3. And of course, for the denominator, x is equal to 0. So the zeros are 5, negative 3, and 0. Now, our number line so let's say 0, 1, 2, 3, 4, 5. Okay, I will adjust it on the middle part. Let's say 0, 1, 2, 3, 4, 5, 6, 7, negative 1, negative 2, negative 3, negative 4, and negative 5. Now, locate our zeros. Positive 5. So it's here. We have the 0 and negative 3. Okay, that's it. Let us test whether the numbers on the left side of negative 3 satisfies our inequality. Choose between negative 5, negative 6, negative 4, or negative 7. Okay, let us try 5. So if x is equal to negative 5. So negative 5 minus 5, negative 5 plus 3 over negative 5 is less than or equal to 0. Let us check. Negative 5 minus 5, this is negative 10. Negative 5 plus 3, negative 2. All over negative 5. Negative 10 times negative 2, that is 20 over negative 5. 20 divided by negative 5, negative 4 is less than or equal to 0. Is negative 4 less than or equal to 0? Yes. So that means this is true. Negative 4 is less than 0. Now, let us check these numbers between negative 3 and 0. Choose between negative 2 and negative 1. Let us try negative 1. If x is equal to negative 1. So we have negative 1 minus 5, negative 1 plus 3 over negative 1 less than or equal to 0. Negative 1 minus 5, that is negative 6 times negative 1 plus 3, 2 over negative 1 less than or equal to 0. Negative 6 times 2, that is negative 12 over negative 1 less than or equal to 0. Negative 12 divided by negative 1, that is 12 less than or equal to 0. 12 is less than 0, true or false? False. So this is false. That means if it is false, the numbers between negative 2 and 0 are not included. How about these numbers? 1, 2, 3, and 4. Choose one. Okay, I will choose 3. If x is equal to 3. So change x to 3. So 3 minus 5, 3 plus 3 over 3 is less than or equal to 0. 3 minus 5, that is negative 2. 3 plus 3 is 6 over 3, less than or equal to 0. Let us use the cancellation method. 6 divided by 3, that is 2. So negative 2 times 2, this is negative 4 is less than or equal to 0. Is negative 4 less than 0? Yes. So this is true. And last, 6, 7, 8, 9, and so on. So let us choose if x is equal to 6. So 6 minus 5, then 6 plus 3 over 6 is less than or equal to 0. 6 minus 5, that is 1. 6 plus 3, that is 9 over 6, less than or equal to 0. So 9 over 6 is less than or equal to 0. 9 over 6 is 1 point something. So this is false. That is not satisfies our inequality. So let us cross out the false. Okay. And now write in our interval notation for our final answer. So in this part, going to negative infinity, that satisfies our inequality. Negative infinity to negative 3. We're going to close at negative 3. Union, on this part, this is true. 0 is included. But, open or close? We need to open 0. 0 is not included. Why 0 is not included? Because if x is 0, that will give us undefined or extraneous solution. So we're going to open to 0. 0 is not included. To positive 5, we're going to close to positive 5. This is now our final answer. Negative infinity to negative 3, union, open to 0 to positive 5, close. This is our solution in that given problem. Thank you for watching Senior Problem TV, and I hope you enjoyed and you learned something in our tutorial videos. Please share to your classmates.